Hello everyone, welcome to AI Anytime channel. In this video, we are going to see some of the techniques that will help us implement better RAG system. Okay, so RAG means Retrieval Augmented Generation. One of the most prominent, applications of, generative AI or LLM in general. Everybody wants to build a RAG, a system for their knowledge bases. Now, RAG is extremely helpful when you don't want to fine tune a particular model, but still, you want to generate some kind of insights on your knowledge base. Now, imagine if you have number of documents, images, audios, and videos, how can you use a mechanism that will help you retrieve some kind of information from those documents, and you can also generate some answers based on your queries, right? So it's a augmented generation. We call it retrieval augmented generation, where you combine a couple of models. So first part is the retrieval and the second part is the generation. So for retrieval we use some techniques like semantic search, and for generation we use a large language model or a language model to look at the retrieved chunk or the retrieved documents and then form a human like response. That's what RAG basically means, on a very high level, not that technical. So RAG is really, I'll say, crucial for an enterprise who don't want to really fine tune but still want to, generate some kind of responses from their data. Now, it's not that easy to build a efficient and accurate RAGs workflow, right? And that's where we are going to see there are some techniques that I'm going to cover in this video, and the focus of in this video will only be till retriever. We'll cover the generation part in the next video. Okay, so let me first start my notebook here, and then we'll start writing code, and then we'll explain throughout this video. Now I'll just open a terminal here, so more options, or rather let's open this in Anaconda. So I'm just gonna go Anaconda prompt, and you can see I'm opening Anaconda prompt. I'm going to use Anaconda in this video to write the code in a notebook. Now here you can see I'm in a based environment. If you want to find out how many envs you have, you can do conda env list, to find out how many environments do you have in your Anaconda in your system. I only have one base, and I'm going to just go inside this directory, and let me just do a Jupyter notebook here. Once I do a Jupyter notebook, it will open a notebook in the browser. Okay, so you can look at it. I have something called data. Let me first show you the data, that what are the data that we are going to consider in this video. You can see that I have two data, two PDFs here. Okay, and let me just bring my monitor up, and if you look at the data here, the one is called Paris Agreement and the other is HDG goals. Now in this video we are going to look at some sustainability related or some climate change related source document. If I open this document here, UN HDG, let me just minimize this. You can look at what it calls. It calls 2030 Agenda for Sustainable Development. It's a document by United Nations on the HDG goals. We have 17 HDG goals that you can find it over here in the document. Now, the other document is something called Paris Agreement, which also talks about sustainability, climate change, and a lot of other. You can find it over here, right? A lot of other things between a developing nation or developed nation, and a lot of other agreement that has happened between different nations. So we're going to consider these two documents as source document. Let me close all tabs. Now imagine if you have n number of documents. Okay, here you have, for example, you have one document for life insurance, you have the other document for your auto insurance. You will not probably create a single vector database or a single vector store, and that's what we're going to cover in this video, that how we can look at some different techniques to build a better RAG. You cannot create a single knowledge base for different kind of documents, where then it will be very difficult for a retrieval model, like where we do a semantic search to retrieve the right set of documents. That's the first thing we are going to talk. The next thing that we're going to talk is something called lost in the middle. Okay, so LLM struggles when it comes to looking or scanning at the context who are in the middle of your retrieve documents. Now imagine if you have 10 number of documents that has been retrieved when you are performing a semantic search. LLM basically ignores the middle context. It only looks at the first context and the last context, or the first document or the last document, whatever you call it. And that's what we call it lost in middle, which is a research I think done by Stanford, if I'm not wrong. Okay, so it's a very famous paper that you can read. I'll give the link in the description. And that's what we're also going to look at in this video. So we'll look at first creating different vector stores, merging it together. That's called merge retriever. Yes, we are going to use LOTR, lot of the retrievers by LangChain that provide this feature of something called merge retriever. And then we'll also look at lost in middle. So LangChain provides one more feature that's called long context reorder. You'd heard about the words like re-ranking. So you re-rank the context, re-rank the documents, re-rank the chunks when you perform a semantic search. These are two things that we'll look in this video. I will not make this video too long. In the upcoming videos, we'll also look at ensemble retriever, which is more of like a both like it's a hybrid search which looks at both sparse vectors and the dense vectors. So both embedding based and the keywords based search. Okay, so we look at ensemble, which is more of like a reciprocal rank fusion algorithms. Merge retriever is little different. It's a round robin fashion. So we'll talk about all of this. We'll execute it here in the code base, and I will show you a live example at how the retrieval works and how you can re-rank the retrieval. And in the next video, which is the second part of this video series of building better RAGs, we will look at ensemble retriever and also now look at some combined chains like we are building right now. So now let's jump in. So here I already have this Jupyter notebook and I have my data folder, and I'm going to create a notebook here, which is Python 3.10 version. So let me just open a notebook here and I will start writing my code. Now the first thing that I'm going to do is import OS that helps me get some documents, etc. if required. And I'm going to use ChromaDB in this case. You know, I have few videos on Web8, Qdrant, Pinecone. Please find those videos in the LLM playlist. It depends which vector database or vector store you are working with. Now ChromaDB, the next thing that I'm gonna do is from LangChain, or this would have directly used from LangChain. So from LangChain dot vector stores, I'm gonna import import chroma. I don't know why it's adapters, sorry. LangChain.vector stores import chroma. This is the next thing. Now we also need, let's also from LangChain.document transformers, and I'm going to use something called long context reorder. So let's do that. So long context reorder, that's what I'm also gonna import here, you know, in this. Now from LangChain dot let's from LangChain dot from LangChain dot probably let me just I cannot see it due to less charge in my system. Now what are the things that we need? So we have a PDF, so we need a PyPDF here. So let's use from LangChain dot document loaders. This is really bad, document loaders, and I'm gonna import PyPDF loader. Let's use PyPDF loader. The next thing that we need an embedding model, and I'm going to use BGE large embedding model, which is an embedding model, one of the best embedding model, which performs better than MPNet and MiniLM by sentence transformers. It's by Beijing AI Academy, one of the best performing embedding model right now. So I'm just going to use that model here. So from LangChain dot embeddings, and I'm going to import Hugging Face embeddings, and let's also import Hugging Face BGE embedding, that is for BGE. Now what else we can what else we need here? So PyPDF is done, and we need merge retriever. So from LangChain dot retrievers dot merger retriever, correct? And I'm going to import merge retriever. Let's, and I think we are okay with this import for now. So long context reorder is also done, merge retriever also done. Now let's first get the embedding model, guys. So for that, what I'm going to do is, let me just do markdown here, and I'm going to write get the embedding model. Okay, so let's get this embedding model, and for that let's define a model name. So this model is available, let me show you here. You can look at BGE embeddings Hugging Face. I'll give the link in the description. You can look at here. It's by Beijing AI Academy. That's the model I'm going to use. BGE Large English. That's the embedding model we're going to use here in this video. Now, so model name, let's copy that from there. Excuse me. I'll just copy this here. Copied, and I'm just going to paste it. This is the model name. Now, let's define some model quarks here. So model quarks, and I'm gonna use CPU here. If you have a GPU machine, feel free to use CUDA here. Now device CPU. Now it also has some encoding quarks. It's not encoding, it's encode quarks, by the way. RGS encode quarks, and in this I'm going to use something called normalize embedding. If you want to normalize the embeddings, in my case I'll just keep it false for now. Okay, so normalize embeddings, and let's keep it false. Now let's have a variable called HF, and here I'm going to use Hugging Face BGE embedding, and inside this I'm going to use model name. So my model name is nothing but its model name. So let's use the model name, and after that model quarks. My model quarks is model quarks, and then I have encode quarks. So encode quarks is encode quarks, and here let's write print embedding model loaded. You can use any other model, embedding model as well. So if when you are running it for the first time, this piece of code, it will take a bit of time to load the model. So it will first download and keep it in your cache, right? It will get the model weights from Hugging Face, and it will store that in your cache memory, you know, that wherever you are running this right now. So you can see I see a message here that's called embedding model loaded. So in my case, the model has been loaded successfully. Now let's go into some data pre-processing step, guys. So what I'm going to do here, let's do a markdown here. So markdown data pre-processing, and so we have to load the PDF, and then extract the text, load and split using recursive character text splitter. Will have a basic chunking strategy, but that's also important. So let's call it loader un SDG, a variable loader un SDG. I'm going to use PyPDF loader, and inside this I'm just going to pass the file name. So it is data. So let me just, I hope it shows me, and you can look at these are the files that I have. So the first is un SDG PDF. So first let's do it for, let's first do load and split for this PDF, and then we'll just copy paste. Now documents un SDG. So let me just do documents un SDG, and I'm going to use loader un SDG dot load. So I'm just going to call it load function here, and that will load the file. Now once I load the file, I'm going to do a text splitter thingy here. So text splitter un SDG. Now text splitter un SDG, and let's use recursive. I think I forgot to import that. So from LangChain dot text splitter, import, what is that? Recursive character text splitter. Now I'm just going to use recursive. It's not showing me because I just imported, by the way, text splitter. recursive character text splitter, and here I'm going to write the code. So chunk size, what is the size of chunks and the chunk size that we are defining, right? So I'm going to call it 1000. Keep a higher chunk size, if you have like bigger paragraphs in your PDF, right? And if you want to cover like good amount of chunks, right? That you should keep a chunk size higher. So chunk size is 1000, and I'm gonna keep chunk overlap. So let's do chunk overlap here, and I'm just gonna call it 100 for overlapping of chunks. Now this is done. So now let's have text UNSDG, a variable that will split that. Now let's have text splitter UNSDG dot split documents. Okay, so I'm just gonna use split documents and split documents, and here I'm going to use documents UNSDG. Now here what we assuming is, guys, that this will split your PDF file, whatever we have, all the chunks that we've created on 1000 chunk size, and then we can, it's basically a list, so you can find out what is in the first list. Now let's run it, and once you run it, let's see, it will take a bit of time because that UNSDG has some good amount of pages in that PDF, and it says recursive character text splitter is not defined. That's okay. What didn't we? Let me just copy this thingy here. Recursive character text splitter. I don't know why it says it's not defined. Is there a typo or something? I don't know. Recursive character text splitter. But anyway, let's see that. Okay, now you can see that we didn't get there. Now let's first do a text UNSDG and look at the first of the list. Okay, there's again a typo, guys. Now let's do, and you can find out, right? Let me look at the fourth one. If you look at fourth one, let's look at 10th in the list, and you can find out, right, how it has splitted. Or chunking strategy is really important, guys. You have to do better chunks. There can be different chunking strategies. You can chunk, you can create, you can split this on headers, subheaders. You can also load it through a JSON, etc. This is very intuitive to do. It's a trial and error experimentation when you are building a RAG system. Now we'll copy the entire thing here, guys. So let's copy this for let's copy this for Paris agreement PDF. So I'm just going to call it Paris agreement, and this will get changed here. So let me just remove this and call it data slash. Once I do slash, I can find out that PDF is there, and this will also get changed here. So it will become loader Paris agreement, and this will be also, let's call it Paris agreement. Now this will become Paris agreement as well, and this looks nice, text Paris agreement. So let's do that, and here this will also be changed now, splitter Paris agreement, split document, and this will become UNSDG's document, and this will become document Paris agreement. Let me just have a look quickly. Load the Paris agreement to Paris agreement, fine. Paris agreement, fine. Text splitter Paris agreement, text, fantastic. Now let's run it for that, and it has less pages. So text Paris agreement, and look at what's inside this, and you can see that we have now created chunks now. Now let's create the vector store. Now we already have an embedding model initialized. We now have we have done our load and split thingy. Now we can create the vector stores here. Okay, so let's create and store vectors. Create and, excuse me, let's make it create and store vectors. And as you know that uh, we are using Chroma DB here, so let's do that. So what I'm going to do here first is for UNHDG. For the first PDF, we are going to create set two different vector stores. One is for the SDGs and the other for the Paris Agreement. Two different PDFs we have. We'll create two different vector stores, and then we'll use merge retriever to merge it all together, and then we'll use round robin algorithm that will do it for you. You don't have to do it. Okay, so the backend is like the underlying algorithm is a round robin algorithm that looks at the top documents in a round robin fashion and then just return it from the vector, the merge vector. I'll explain that maybe with some examples. Now UNSDG store, and here in this what I'm going to do, chroma dot from documents, because we are creating right now, we are not loading already created vector store. That will only be chroma. Now here the chroma dot from documents, and the next is text UNSDG, because that's what okay. And now what here, this is really important, guys. The reason is, now, why are we doing this? Let me just bring up my screen quickly. Okay. Ooh. Now, here I will tell you that how you can define some configurations when you are creating this vector store. Okay, so first thing is that it has different ways of performing search, different algorithms. You can use cosine similarity to find out similarities between the vectors. You can use Euclidean, you can use different, whatever it supports, right? It supports IP, cosine, Euclidean, L2 dot, etc, 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 right? All these terminologies. You have to look at Chroma documentation. I think they support three different type of algorithms for search, similarity search, but you can also find out on their documentation. Now here, okay, let me make it a little bigger so you can see. Now text UNSDG. Now what I'm going to do next here is I have my embeddings in HF. That's where your HF model is, and here I'm going to define a collection metadata. Now in this collection metadata, you can configure explicitly if you want to use cosine, or if you want to use IP, which is for dot, or if you want to use something else, you can define it here. Now in the collection metadata, it's a dictionary. It accepts a key value pair, and that's all. That's called like HNSW. So let's define HNSW, and in this HNSW, we're going to have a space, and then we'll have here that which algorithm we are trying to use, like here. So I'm going to keep cosine. Okay, so let's use cosine for this, and then you can persist this vector in your disk. Okay, so I'm just going to call it like it's an in memory, right? So let's use persist directory, and here let's have store, and then you can create like un vector cosine. Okay, now what if you look at what we are doing here, we are specifying the configuration that we are saying, okay, you use this cosine features of Chroma DB that provides. Now if you want to use IP, maybe you can also find it out here. Let me see if I can give the link in description. Collection metadata Chroma DB. If you look at the UJS guide, let me walk you through quickly. Now I'm on their documentation. If you come down somewhere, you can look at the collections here. Now in embedding function, this is fine. This is just loading it from there, not that one. Yeah, this is what I'm trying to show you. If you look at this piece of code here, it says also takes an optional metadata argument which can be used to customize the distant method of the embedding space, that the space that you have, the n-dimensional space, okay, that which similarity or the distance algorithm you should use, the method so you can look at here, right? This is what it supports. It supports IP, L2 or cosine. It's Euclidean, The default is L2, by the way. So if you don't use it by default, it will be L2. It will not be cosine or IP, which is for dot. Okay. So I'm gonna go with cosine here, guys. So let's run it and see. Now, once we run this part of the code, you will see that it will take a bit of time to create the vector store for this particular document. But for this, we are just creating a knowledge base, an n-dimensional space in which an embedding model can go and retrieve when based on your query, it can perform some semantic search. That's what the task is here in this. Now let's copy the code for Paris as well. So for that, I'm just gonna call it Paris. Let's do it. So Paris. Oh, this is really surprising. Paris and Paris agreement store. So this is what I'm gonna call here, and this text UN HDG will replace by text Paris agreement. And your HF remains HF because that's the embedding model. If you want to use one more embedding model that I will recommend you to use, because that's the purpose of probably using a merge retriever, because if you use two different embedding models for two different knowledge bases, there will be less chances of biases. You will be able to mitigate some sort of biases because a single embedding model for both the knowledge bases can be biased a bit, but if you use different embedding models, you can use that. You can use sentence transformer models like MPNet or MiniLM or OpenAI embeddings or Vertex AI, Gecko embedding, whatever. Okay, that depends. But maybe you can try it out and let me know in the comment box. Now, here we have HF, collection metadata, persist directory. Now, in this case, let's change the name here from UN to Paris. Okay, so persist store, and you can see this is currently it's taking time because there's an n number of PDFs. I think it's around 70 or 80 number of PDFs that we have. So let's wait for it and then we'll run this one. Maybe let me write the next markdown here. Okay, this is not the markdown. This is code, by the way. I'll add a new cell here, and in this let's call it markdown, and in this markdown I'm gonna call it load the vector store. Load the vector store. Load. Okay, I ran it because it's a markdown, so your code will not get disturbed. Now we will first create and persist. Even it's an in memory, it's better to persist. Have a couple of folders because you don't have to run it every time. In a runtime when you are performing a semantic search. Better is to first ingest all the file, create the vectors, and create it in a store or a DB, whatever you are using it, and then just load it from there and perform semantic searches. Latency will also not be an issue there. Now, it's taking a bit of time. Embedding is an expensive thing, guys. If you use something like matching engine or open source service or like on the cloud hyperscalers, that's also a pain, to be honest. Now let's load it. By the way, let's write the code once it's getting created. Now UN SDG store. And how do we load it, guys? We only load it from Chroma. We don't do from document because that's only for creating the embeddings. Now here Chroma, and I'm going to call it persist directory again. I'm just going to use the directory where I have saved it, and we have saved it, and store UN vector and cosine. UN vector cosine. Okay, and here you're going to pass your embedding function, the embedding model that you have through a function, embedding function that will take care of it, all of your computation of vector creation for your query. So now once you ask a query, you also have to create vectors for that particular query. Then it can only go and in the existing n-dimensional space of vector store and find out the relevant vectors. Okay, so vector is nothing but the numerical representation. That's it. Now, which has both, if you talk about in the terms of physics, it has both magnitude and direction. Okay, now load event store, SDG store. Let's load the same for Paris thingy. So Paris agreement store. and here I'm just going to call it chroma persist directory. There's a typo. Persist directory store, and what was that? That was Paris vector cosine. So let's do that. So Paris vector cosine, and here I'm going to just write the embedding function, and that is your HF, which is sort of hugging face. Now here we load both the already created vector store, and let me add a couple of more cells, and here I'm gonna use one more markdown, and I'm just going to call init merge retriever and perform semantic search. Okay. Ooh. And let me just come down. Let's it's taking a bit of time, guys. Probably I think I should pause the video here and come back once it gets completed. So let me just do that. Let me pause the video here, and I'll come back once the vector is created for both of it. So you can see that it has been created successfully, both the vector stores. You can look at here something called Paris vector store, Paris vector cosine, and the other is UN vector cosine. So both the vector stores have been created here successfully. Now if you go inside it, guys, Chroma has been migrated from DuckDB Parquet to SQLite. So they have migrated, in the last few months. So yeah, if you are still using the previous version of ChromaDB, you might get some errors. So just for your information. Now, if you go inside even vector cosine, you will find out something called SQLite that has schema, of all of your vectors, and here are all of your chunks, etc. that you can find it out. It has been, again, it works on serialized and deserialized mechanism when you work with the vector store. Now here we have something called Paris vector cosine, and so we have now two different vector store. Let's merge these two different vector stores. You can merge n number of vector store here. Let's see how we do it. Now I already have loaded this. You can see it over here. We have loaded this already created vector stores, and now we're going to merge the retriever and perform semantic search. Now let's call it retriever UNSDG, and here I'm going to call it load UNSD store dot and dot as retriever. Yes, as retriever, and inside this I'm going to pass a couple of things here. The first thing is the search. The first thing is search type. Now search type also provides also has different options. You are looking at something called similarity. It provides something called MMR, which is for maximal marginal relevancy, that looks at of course, it again looks at the most similar responses or chunks, whatever query that you have asked, but it looks at diversity. Okay, when it comes to MMR, so it has MMR, it has similarity. For simplicity in this video, I'm just going to go ahead with similarity, but it's you have to try. You can play around this different type of search type. So I'm going to keep similarity, but you can again play with MMR as well. It's just simple as that. You just have to write MMR, but that's an acronym is for maximal marginal relevancy, that looks at the diversity candidates in your retrieved document or inside your vector stores. So search type similarity, and it also you can also provide some arguments here, like you can also set up a threshold values. Now if you are not getting the right results, now you can also put a threshold value of, for example, 70. So anything which is having higher than, I think it's not, it is 70 or 0.7, whatever. I have to look at that. Okay, so if it's like 70%, then only retrieve those relevant chunks. So you can also play around those arguments as well. But here I'm just going to call it search quarks. So let's do search quarks, and inside this search quarks, the first thing is how many documents I want to retrieve. So I want to retrieve 3 documents. So let's call it number of k as 3. And here, what I'm also going to do here in search quarks, So search quarks is basically it's a key value pair. Okay, when you look at that. So what I'm going to do now, after this, I'm also going to include metadata. So let's do include metadata, and I'm going to call this it's a boolean value, so let's call it true, include metadata. Now I'll just copy this entire thingy here and just going to control C and just going to do control V. Now this that you see, it's for first one for the UN HDG. Now we'll do it for Paris as well. So let's do Paris agreement and retriever Paris agreement. This will also get changed. This will be load Paris agreement store dot as retriever. Let's keep it search type similarity as similarity, search quarks k equals true, include metadata. Now what it will do, guys, it will, what we are doing here, we are creating two different instances of retrievers, and then we'll merge those retrievers. So when you merge it together, you will have altogether 6 retrieved documents. Okay, 6 relevant documents that you will retrieve from the vector store. That's what I want to do here. Now once you run it, you will see that it has been initiated successfully. Now let's have a variable called LOTR, and here I'm going to use a merger retriever. So let's use merger retriever class of LangChain. So in merger retriever, what I'm going to do, I'm going to pass a list of retrievers. It takes a list. You can provide n number of lists. This is really important, as I said. Why are we doing this exercise? You will not probably create a single vector store for different type of documents that you have within an enterprise. Now suppose if you have marketing related documents, you have sales related document, you have health related document, you have policy related document. Why would you create a single vector store? Create different vector stores and then merge it together, and then use different type of algorithms to perform semantic search, and whenever you get the search, give it to an LLM to generate some responses. And of course there are some different techniques to even improve the retriever. Like one of the things that we are doing it, then we'll look at long context reorder, how we can do a re-ranking of the retrieved documents. Now here in the retriever, it takes a list, and the list I'm just going to pass my retriever. The first is retriever UNSTG, and the second is retriever Paris agreement. Okay, and let me just merge it. Now when you just do LOTR, you will see all of the verbos here, like merge, retriever, text, metadata, blah 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 blah, right? Or as simple as that. Now we have done this. Now what I'm going to do next here, guys? Okay, so let's define a query here. Let me just do a query and perform a semantic search. This is what we are going to do in this video. Probably in the next video we'll start from where we leave here, and then we'll start from there, and we'll also go into the generation part, the chain part of it. Okay, the retrieval QA chain, or the stuffed documents chain, or rephrase query retriever chain, whatever. Now here in the query, now let's ask a question. What question we can ask, guys? That also now a topic of discussion. Let me just look at the let's look at something like okay, let me hear. What does the rule, no, not rule, what does the goal 16 talks about? This is your query. Now let's have a docs, and in the docs I'm going to use get relevant document method. I'm going to call it LOTR dot get relevant. You can see it's not a get get relevant documents, and in this I'm going to pass my query. So let's pass your query and just do a print docs. Now once we do that, you will see here, let me just make it bigger so you can see it, control plus. Now if you look at the retrieved responses, it gives you, let's first count the page content, and you're going to write some post processing function, the output parser, to parse the outputs in a better way. Now if you look at the document page content 1 2 3, it should be a total of 6. So 1, and then we have 2, then we have 3, then we have 4, then we have 5, and then we have 6. altogether we have 6 here, the retrieved documents. And if you look at the page content, first talks about the goal 16, promote peaceful and inclusive societies for sustainable development, provide access to justice, all build effective, accountable, inclusive institutions at all levels. Now if you go back to documents, let's look at you can look at this goal 16. It retrieves the right set of information. That's what it retrieves. So this is okay. Now let's look at something else quickly to show you. Okay. Okay, it has, oh, it has given the detail, guys. Okay. Let's ask. Hmm. Okay. Global Sustainable Development Report. Okay, let's ask one more question here and ask about what is the global sustainable development report? What is the role of, let's ask this query, what is the role of global sustainable uh, development report? And once I ask this query now, let's find out, okay, if it has retrieved the right set of document. Okay, let's have a look at that. To data even STG, this is fine. So even STG is three dimensions. I don't think so, guys, that it's able to retrieve the right set of document in the first. Now why we're talking about lost in middle. Now what do I mean by lost in middle, or what do we mean by lost in middle, LIM, where LLM struggles? Now if you look at the first, this is your first document. Okay, this is the top document, and if you come down you will have your below document. If you look at this here, now LLM struggles with context which are in the middle. If you look at these context, right, LLM struggle with this piece of context. When your context, like you have n number of context, for example, if you have more than 5 context, when you have context, there are performance degradation. There are no doubt about it. You will have degradation, they will have less performances or efficient performances, thereby a retrieval. Okay, and that's where we have to basically re-rank this context, and that's where we take help of long context reorder. Let me show you what do I mean by long context reorder. Now how will you do a long context reorder in this guy? So let's have a look in that how we can use a long context reorder class by LangChain. Now in that case, if you don't want to use LangChain, if you want to use your own like piece of code, or you want to create your own function, you can look at something called cross encoder model. You have a lot of BERT model that helps you basically deal with this issue. So now let's create here something called to code markdown, and in this markdown, this is going to be the last part of this video, and we're going to do long context reorder. Okay, so long context reorder, lost in the middle problem fix. Now how do you do it? So let me first see if I have. Okay, I think I have. So let's call reordering. Okay, let's have a variable called reordering, and in this variable we're going to use the long context reorder class by LangChain. That's already given by LangChain, so you don't have to worry about it. It's a very high level abstract classes that LangChain provides you, but as you want to do it yourself, you can do it. And some of the vector databases like Weaviate provides re-ranking features. They have inbuilt when you set it up locally, so you can use those options as well. Now to keep it simple, let's first initiate this. Now I've initiated long context reorder. What I will do, guys, I will pass the above document that we have, docs. So let's call it reorder doc, and let's pass it over here. So reordering dot, and I'm going to use transform documents function, and here I'm just going to pass the docs. So the previous docs I'm going to pass. And now let's print the reorder docs. Now once I pass the reorder docs, let me show you. If you look at the response in the previous context, this was second. Accelerating, encouraging, and enabling innovation is critical. Now if you come down, accelerating, encouraging, and enabling innovation becomes the first part of the context. Right now in this, we are not manually checking it. It does not necessarily mean that if you do long context reorder, if you re-rank it, it improves. But in the most of the scenarios, we have noticed that re-ranking, which is based on reciprocal rank fusion RRF algorithms at the most of the places when you use this algorithm, they tend to improve the performances by re-ranking the relevant chunks of the retrieved documents. And you can find it out over here, right? The second becomes first, because if you find out here, let me just show you. Lost in the middle LLM, I think it's by Stanford, or I think someone. Okay, you can look it over here, right? That's what I was talking about. Lost in the middle. How language models use long context. They kind of, like they get confused, or they ignore, most of the time. Now, if you click on download, PDF, let me just download this PDF and let me show you. Okay. It's a really good paper. I'll give the link in the description. Please read this paper and try to. It's by Stanford, as I said rightly, right? You can go through it and find out that what are the issues when you use this long context. So n number of context. Now there are some other topics that we are going to discuss in the next video, where we'll start from here only. We'll start with contextual compression that helps you also mitigate the biases and remove redundant chunks, redundant documents. And then we look at ensemble retrieval, which is more like a hybrid search. And then we look at some other techniques to improve the performances of your RAG chain, or to help you build better RAG system. So in this, I covered LOTR, which is merger retrieval, which is an acronym for lot of the retrieval, which is provided by LangChain. And then we looked at long context reorder that helps you re-rank the algorithm. In the next video, maybe I'll also cover how to do it manually through cross-encoder models, through some cross-encoding bot models, etc., to do that. So that's all. In this video, we're not looking at the LLM right now. We'll use this relevant chunk or the retrieved documents. We'll pass it to LLM and we'll compare the output in the next video. Otherwise, it will really get longer. So this notebook will be available on my GitHub repository, guys. If you have any question, thoughts, or feedback, please let me know in the comment box. If you have any questions, you can reach out to me through my social media channels. Please find that on YouTube banner and the channel about us. And if you haven't subscribed the channel yet, please do subscribe. Please watch my previous videos on LLM and different generative AI related videos. Please share the video and the channel with your friends and to peer. Thank you so much for watching. See you in the next one.